Now coming back to this tab, on chip debug setting. So on chip debug operation setting, it is clicked on unused, but I'll put it on use. Then you need to select the type of emulator that you're using, the hardware. When you're using the hardware MCU, then you need to select the hardware emulator that you are selecting. So we have options from E1, E2 and E2 Lite. E2 Lite is the cheapest one for RL78 MCUs, just highlighting that point. Okay, then there are some other options available over here, sudo rrmdmm, so we'll not get into this. Some security setting is there. So what is the security setting is that if you program your microcontroller through a particular security ID, and while reading it, or while security ID authentication fails while reading it, so we have the option that erase flash memory data. If someone is trying to like copy the flash content of your microcontroller, and his security ID is not matching, hence the flash memory will be destroyed automatically, so your code is safe. Renesas, being a Japanese company, they take care of these things to a very greater extent, because their priority is safety and security. Yeah. So moving further, output the functions for confirming. This is not for our purpose as of now. There are some safety functions which can be discussed later, not on basic level. There's data flash. So if you happen to use data flash of this microcontroller, then we need to enable these and this. But debugging in while debugging, this thing cannot be used, so we'll let it remain, and we'll take this up in a separate session on data flash. So yeah, we are done with this. Now see that all the peripherals are written over here, and this watchdog timer peripheral is basically open. It remains used automatically. I recommend you to unuse it for this demo, because what happens, this watchdog timer resets the microcontroller if you do not call the watchdog timer function. So we do not want to get into the watchdog timer thing as of now. We are just going to learn how to use an LED, turn blink on and off, and that's all. So yeah, we'll save this. How to save this? Save project, save all. Yeah, just put save all. Now generate code. Okay. Yeah, so once you generate code, so these kind of files are basically generated, and this is the main file. Okay, this is the main file. This is the while loop. Just like an Arduino code, there's a while loop, and if there's a part of code that needs to be initialized only once, so you can use this function to define those things or declare those things, or whatever, call those things. So this is that function that is called once, and EI basically enable interrupt. So you need to understand that your function that you are calling should be called before this or after this. So enable interrupt, yeah, that's the thing. So now our purpose is to basically turn on and off an LED. So for that we are going to use the port peripheral. Okay, on the port peripheral, try to understand that these are the number of ports that we are getting. Okay, yeah, these are the type of ports that we are getting. We are having options of pull-ups also on some particular pin, some N channel drain output, some TTL buffer output. So these N channel drain and TTL are basically used at the time when you are giving it as output. Yeah, N channel drain and TTL, or as input also. Yeah, TTL is a voltage level. There are basically two technologies, CMOS and TTL technology, so the voltage level differs, so that is what it is. We'll get into the detailing in some other videos. So as of now, what we are going to understand is that this is our MCU, okay, and how this naming is done. So if I talk about P62 or P63, so what P62 or 63 basically means is the second pin of port number 6, that is pin P62. So the first number is the port number, and the last number is the pin number. So just remember the last number will be the pin number, because if there is a pin which is having like 3 digits,